All right, hello again, everybody. We are going to be doing the second day of the quadratic formula, but let's first start with this do now. It says which value would be a solution for x in the following inequality. Okay, so we have 47 minus 4x is less than 7. So to solve this, we have to get x by itself. So our first step would be to subtract 47 on both sides. We'd be left with negative 4x is less than negative 40. To get x by itself, we have to divide by negative 4, and we'd be left with x on this side and 10 on this side. Keep in mind, since we divided both sides by a negative number, the inequality has to switch. So this reads x is greater than 10. Now, in the problem, it said which value would be a solution for x. So x has to be greater than 10. Here we have two negative numbers, so that really doesn't work out. Now, between 10 and 11, we don't have greater than or equal to 10. It just has to be greater than 10. So that's why 4 would be our answer here. Okay, so a quadratic equation is an equation that contains x squared. It's important that you are able to identify when you use these procedures. So we have done solving by factoring, by square rooting, and we're going to continue with the quadratic formula. I'm sorry, I really don't know why this is not calibrated, but just bear with me. So, quadratic formula, very, very important. You don't have to memorize it. It's given to you on the Regents. And to identify A, B, and C, A is in front of x squared, B is in front of x, and C is your constant. So, find the roots of 4x squared plus 4x minus 8 equals 1. Our first step is to get this equal to 0. So what we have to do is subtract 1 on both sides. Now we're subtracting 1 from the 8 because those are like terms. So we have 4x squared plus 4x minus 9 is equal to 0. Now, since this is in standard form and it's equal to 0, we can identify A, B, and C. So A here is 4, B is also 4, and C is negative 9. Don't forget the sign in front of the number. So once we have A, B, and C, we can plug them into the quadratic formula. So first I'm just going to write it, plus or minus the square root of b squared minus 4ac all over 2a. So now let's plug in all of our values. X equals negative, b was 4, plus or minus square root, b is 4, squared minus 4, a was 4, and c was a negative 9. This is all over 2 times a. Okay, now I'm going to just bring the work up to here. Remember, we want to get 3 numbers from this. We want x equals a number in that box. We want the number underneath the radical. And we want the number in the denominator. Okay? So let's fill in what those numbers are. So here we have a negative 4. So this is a negative 4. In the denominator, we have 2 times 4, which is 8. Now let's find the number underneath the radical. To do that, you go to your calculator and you only type in what's under the radical. Do not type the radical in your calculator. So we have 4 squared minus 4 times a times c. And that gives us 160. So 160 goes underneath the radical. So I'm just going to rewrite this, but let's try to simplify that radical 160. Let's see if it is a perfect square. So when we try the radical of 160, we get this decimal. We do not write that, okay? So we keep it as radical 160 for now. What we are going to try to do, though, is see if we can simplify that radical. Now, to simplify radicals, remember we have to use perfect squares. So I'm going to simplify this on this side. We have to try and find the biggest perfect square that goes into 160. And I'll list them up on the top. So perfect squares. So our perfect squares we get from doing 1 times 1, 2 times 2, 3 times 3, and so on. So 4 times 4, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. If you want to do a little bit more, 11 times 11, 12 times 12, and so on. So we're going to use this list to help us figure out what's the biggest perfect square that goes into 160. So we start with 160. So let's divide this by the first perfect square that's smaller than it, which is 144. This does not give us a nice number, so that does not work. So let's do 160 divided by the next perfect square, which was 121. Still does not work. 160 divided by 100. Still does not work. We need a whole number. 160 divided by 81. Doesn't work. And I'm going to keep going. Doesn't work. Now, if you can identify it from the start, that is awesome. I'm just doing this to show every single step in case you can't identify it from the start. Still haven't found it yet. Still haven't found it yet. And now I found it. So we can split this up into radical 16 times radical 10. Okay, now only one of these is a perfect square. The square root of 16 actually gives us 4. So this splits up into 4 radical 10. So in our answer, we are going to replace what we have with 4 radical 10. Now you can see your answer written like this. So this, what we just wrote, could be an answer. But you can also see this answer simplified even more. So I am going to show you how to simplify it more in case you do come across that. So what we can do is actually divide that 8 by both terms. So we can do -4 divided by 8 plus or minus 4 radical 10 divided by 8. Now, -4 over 8. If you want to use the calculator to find what that is, -4 divided by 8, it gives us -0.5, or if we change that to a fraction, it gives us -1/2. So this would be x equals -1/2 plus or minus. We again have a 4 over 8. We do not combine that radical and that 8. So we can only do 4 divided by 8, which we did before, was 1 over 2. And the radical 10 can stay on top. Now to fix this answer a little bit, you might not always See that 1 there? It's not necessary. So you could see this answer as radical 10 over 2. You cannot divide what's in the radical and what's in the denominator because the denominator does not have a square root as well. So this can also be a possible answer. Both of them would be fine. All right, let's try another one. It says find the roots of 2m squared minus 3 equals 7m. First step is we have to move everything to one side. So we have to subtract the 7m. When we subtract the 7m, we get 2m squared minus 7m minus 3 equals 0. We cannot combine anything on that side because we have no like terms. So we can identify A, B, and C. So A is 2, B is a negative 7, and C is a negative 3. So let's take these values and put them into the quadratic formula. Let's first write it. And now let's plug everything in. So x equals negative, b is a negative 7. Don't forget those two negative symbols. Don't forget the parentheses either. A was 2. Now we want to find 3 numbers from here. We want x equals a number there, we want the number under the radical, and we want the number in the denominator. Oops, so x equals, sorry about that. So the number that goes in that first position, so this one right here, we have to look at this. So negative 7, that gives us a positive 7. 2 times 2 gives us 4 in the denominator. Now let's figure out what goes under the radical. You must use your calculator. So we have negative 7. Oh my goodness. Parentheses, negative 7 squared minus 4. A is 2 and C is a negative 3. And we get 73. So underneath the radical goes 73. Notice I did not type the radical in my calculator. Now, let's see if radical 73 is a perfect square. So square root of 73, it is not. So we have to see if we can simplify it. So let's try to simplify the square root of 73, okay? So let's see if we could split this up into a perfect square. So we take our 73 and we start dividing it by perfect squares. I'm going to start with 64. It doesn't work. Let's try 49. Doesn't work. And then just keep trying perfect squares. Nope. 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 Does not work either. And that doesn't work either. Okay? So 73 cannot split up into any perfect squares. When that happens, that's actually pretty good for us. We can't really simplify anything. So all we get here is x equals 7 plus or minus radical 73 over 4. And this would be our final answer. Now you may also see it split up, so you might see the 4 divided by both terms. So you could see 7 over 4 plus or minus radical 73 over 4. Both of these are exactly the same. So whichever one you have as your answer, you're good. Just keep in mind, if it's a multiple choice question, both of these representations could be there. All right, so we are going to stop there. To get credit for this class, you do have to complete this practice page on a separate piece of paper, and then you will have to upload a picture of your work and your solutions onto Google Classroom. All right, everybody, have a great rest of your day.